So last lesson we talked about how we can integrate. So if we integrate something like this, we would get 3x minus 6x squared over 2. So in other words, we would get 3x minus 6x squared plus c. And then we can use, here they're called boundary conditions. We can use these values in here to determine the value of c. So if we did that, we could say 1 equals 3, lots of 2, minus 6, lots of 2 squared, plus c. Find your value of c, and then write it with the value in. That's what we talked about last time. In this lesson, then, we're going to introduce another application. So we said before that integration can be like the opposite of differentiation. Okay, but how else can it be used? Well, you'll understand better where this comes from actually in year 13 integration. But this is very much sort of resulting from the idea that when at GCSE we wanted to find the curved area under a graph, we used lots of trapezia, and we realized that if you made these narrower and narrower and narrower, you get a better and better and better answer. And that's actually what integration does. We haven't looked at why that works yet, but that's what integration does. So if we want to find the area under a curved sort of function like this, we can integrate. We do first need to know, though, what a definite integral is. So what we've done so far is we've done indefinite integrals. Indefinite, like we're not quite sure. That's why we use the C thing. So here we're going to use a definite integral. A definite integral involves something called limits. Let's have a look. So what's the same and what's different? We're integrating something still with respect to x, but we are integrating between the numbers 1 and 5. And geometrically, this is what this looks like. So doing this is the same as finding the area between 1 and 5 on that particular curve. Okay. How do we handle this differently? Well, it's pretty similar. There's just one extra step. So we integrate as we did before, and we'd get x to the power of 4. We write this in square brackets to show that we have integrated, and then we put the limits on the right-hand side. So we say 5 and 1. Now, what do we do with this? Well, we take this thing when the 5 is put in, so when you have 5 to the power of 4, and then we do the same again with the 1. And you put this in brackets because sometimes the bit inside brackets can get quite complicated. And then we subtract them. We subtract them because this one here finds the area of sort of everything, but we don't want that. We take that one away there. Okay, and that leaves us with the blue part. So this is how we integrate with limits, this is called. And it's very, very useful. Okay, so a couple more examples. So we're integrating this thing here, could put it in brackets, with respect to x, and we're doing it between 3 and minus 3. So what do we want to do? Well, first of all, we actually integrate it, which is x cubed over 3 plus x. Now, you'll notice that I don't use a plus c. So for definite integration, you don't need the plus c. Why don't you need this? Well, you don't need this because you would have that number twice and it cancels itself out. Yeah, you don't really need to know much about that, but people often ask, why is there no plus c when you have limits? Well, it's because you kind of use what's integrated twice and it will just cancel itself out. So there's no need for the plus c. We integrate it and we write the limits up here. And what is this? Well, you put brackets, big brackets for the space in between, the subtraction sign, and then you substitute it in. So 3 cubed over 3 plus 3, that's this one here. And then you do the same again for this. It's very common also to have double negatives with this, so just be mindful of that. So this will be minus 3, probably worth putting that in brackets, minus 3 all cubed over 3, definitely worth putting it in brackets actually, plus minus 3. And we work this one out, we subtract, and we get our answer. Okay, And I'll just show you in a second on the next slide what the actual answer is. But this is what we do. So then I would generally like simplify this, simplify all of this, being very careful with the signs, and then subtract. And as I said, it's quite common to have double negatives. So just be on the lookout for that. A harder example with p as a constant, and we actually have an answer. So we have the working out, the algebra, and we have the answer. So we're going to need to work them both out and compare. So let's start by integrating this thing. So if we integrate this thing, we would get, well, what would we get? We would get 2p x squared, then divided by 2. So I'm going to say we're going to get px squared, okay, plus 7. And we need to integrate that between 5 and 1. And what's this going to be equal to? So this is going to be equal to, so we do this thing again, set up the working out. So p multiplied by 5 squared, so you handle the 5 first, plus 7. Then you do the same for the 1. So p multiplied by 1 squared plus 7. Simplify this, well, we can just do that now. So that's 25p plus 7 minus, well, what's that? That's just p plus 7. So we get 24p and minus 7. It seems to eliminate itself. So 24p, we're also told that this is equal to 4p squared. So can you see here we have a quadratic that we can solve, and that kind of explains why it says 2 possible values. Take a look at the question and just see if you can spot the mistake. So by going quickly, there's something that I have neglected there. What have I neglected? Well, it's this one, isn't it? So be on the lookout that we actually made a mistake there. So this is why you need to check your working out. So this is going to be 7 lots of 5, and this is 7 lots of 1. So this is actually the same. So this will become 35 minus 7. So we'll get 24p, 35 minus 7 plus 28. So that's why you need to check your work. What can we do here? It looks like we can divide through by 4 and then we can solve. Okay, so I'm going to just show you the answers a little bit neater. So for the first one, yeah, we get 12 minus 12. So as I said, this double negative thing happens quite a lot. You can also use your calculator. It is worth saying you can use your calculator to check this. If you look at the button underneath menu, you can type this one in. So you can put your limits in, you put your algebra in. The way you put your algebra in is you use the X button up here, okay? If you do that in an exam, though, it's not enough. You actually need to show this. Yeah? Using your calculator, this is a way of checking your answer. Yeah, that's just a way of checking your answer. And the next example that we did, this algebra one, well, it's not going to work because p is an unknown value. So this is where, you know, just knowing how to do things on a calculator is not enough. So this one here is what we ended up with. You could divide through by 4, which simplified the whole thing, and you got 2 values. P is just a constant here, so any number was okay. It didn't say it had to be positive or anything like that. Okay, pause the video and have a go at the 2 questions on the board. So the first one is like the first one that we did together. Don't forget to check your answer on the ClassWiz calculator as well. Then for the second one, it's like the one that we just did with P as a constant, but here your constant is A, and use the hints. So pause the video and have a go at both of those questions, please. Okay, so I'm going to assume that you have done that one now. So 14, and please verify that with your calculator. Remember, there's no plus C if you do definite integration like this. Definite integration means like the one with the square brackets where you use limits, okay? Don't need plus C. This one here, integrate by treating a just as a number, a coefficient at the front, really. Square brackets, limits on the right. Substituting in should look like this. And you need to be careful. You need to take your time with this here. And then you simplify. So, you say, well, what's that? That's 44. And then I'll have 44. And then minus 4 gives me 48. Okay, so lots of cleaning up, lots of double negatives. And when you answer this, you know that it's equal to 18 because somebody's answered the question for you already. So you sort of go off and you solve this one here. Okay, so that should now take you up to exercise 13D. You do need to practice this one a fair bit, but we're going to keep on going here because we can practice this within the context of looking at areas under curves, because if we want areas under curves, we do exactly the same thing that we just did. I look here, I want to integrate between b and a, so I would say I need to integrate this function here with respect to x between b and a. This is your upper limit, this is your lower limit. Right, find the area, and here's the curve. So it says y equals 20 minus x squared between the curve and the x-axis. So what are my limits? Does it give me my limits? Aha, okay. So we're going to look at a question like with the context where we need to find the limits now. So I want to find the area under this curve. That's what the curve is, okay? So I want to integrate 20 minus x squared with respect to x. But my limits haven't been given to me. Why haven't they been given to me? Well, because I need to find them. So what's this value here and what's this value here? Well, this is a quadratic, isn't it? So I could just use this to get my values. And if we work them out, we get 4 and 5. So 4 is the upper limit, minus 5 is the lower limit. Okay? After that, everything is exactly the same as before. So integrating and substituting, if we integrate, we'll get 20x minus x squared over 2 minus x cubed over 3. And then we'd need to put in those values of 4 and minus 5. So we would put, we'll just sort of show you one, and then I'll show you the answer for a neater version. So you get 20, lots of 4, minus 4 squared over 2 minus 4 cubed. That's meant to be a 3. Well, it's a 3 over 3. Okay, that's the 4. You do exactly the same again for the minus 5. And the advantage of, if you put this in brackets here, you're not going to make any sign errors, any mistakes. And actually, if it's numbers, your calculator will simplify it for you quite nicely. So let's have a look at a neater version of that. So as we said, if we take this quadratic, we can get our limits here. They've actually sort of gone one step further in simplifying. I would show substituting that part, substituting with the x's, in my opinion. But once you get this, you can just chuck a bracket in your calculator. So if it says 80 minus 8 minus 64 over 3, yeah, you could just chuck all of that into your calculator. So that's 152 over 3 minus, and work that one out as well, just to show that you haven't just pressed the integrating function, that you are actually substituting in the numbers, and you haven't made a mistake. So pause the video and have a go at this question here. Remember to write the root and the denominator of a fraction in index form first. Your limits are actually given to you here. Yeah, have a go at integrating that one, please. And remember to check the value, the exact value, with your calculator. Okay, so assuming that you've done that, we should get, what should we get? We should get minus 12, okay, as our answer. I'm just going to double check that answer, actually. So with my calculator, between 4 and 1, And if I can get it to type in the function, so 27 minus 2x, 27 minus 2x minus 9 root x minus, you do need to be a bit careful with the calculator as well because it likes to trap things under the root. So just use the arrow keys if it's not working properly. Minus 16 over x squared. Yeah, I get 12. I don't get minus 12. I get 12, which makes sense because the curve is above the axis. So you should get 12 as your answer for that one. Okay, that's why it's good to check with the calculator. Anyway, that takes us up to 13e now.